All right, welcome back to our second lesson. Again, if you haven't subscribed to my channel, I don't know what you have been doing. It's been, it was a long weekend. Come on now, just do it, okay? Anyways, we are gonna be looking at arithmetic series today, and we'll talk about the difference between the sequence and the series, okay? Let's first look at this question here. It says determine the sum of the numbers from 1 to 100. I believe we looked at this question earlier in the year. I don't know if you remember. If you don't remember, that's okay. So the question is basically asking us to go 1 plus 2 plus blah, 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 like, and then keep going. 49 plus 50, 51, 52, blah, 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 plus 99, and 100. Okay, all the way to 100. So something like this. So how do we find the sum here? Well, there's a pattern here, I suppose, and this pattern really leads us to the formula that will be given to you in a second. But here's the pattern: 1 plus 100. So the first term plus the last term, if you add them together, it's 101. If you add the second term with the second last term, 2 plus 99, that's also 101. And if you keep going with this, then you end up with 49 plus 52, which is 101, 50 plus 51, which again is 101. So I guess to find the sum, man, this 5 is terrible. Okay, there you go, a little bit better. Okay, so the sum, really, what we've been doing is we are taking two numbers added together to get us 101. So, I mean, the first 101 we got was the first term plus the last term. So we can go 1 plus 100, right? That's the first term plus the last term. And multiply by, well, we need to multiply how many the number of pairs of 101s, right? That add up to 101. If you think about it, the first one was 1 plus 100. The second one was 2 plus 99. And then all the way till 49. Whoa, 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 whoa. No. 49 plus 52. And then 50 plus 51. So there was a little glitch on my computer. That's why I was like, ooh. Okay, anyways, there are 50 pairs, okay? 50 pairs of 101s, right? Starting from 1 all the way to 50 plus 51. So 50 pairs. And if you multiply this, I believe this is 50, 50, okay? So that's how we can find the sum of this, these numbers from 1 to 100. Okay, so what difference do you see between the problem above and the sequences that we worked previously? Well, here in last lesson, we were listing out the numbers, right? 1, 2, 3, 4, 5, all the way to 100. Today, what we're doing is we are actually adding those numbers together. So the difference here is we are adding the sequence this time. We're adding the sequence now. Okay, so not just listing out the numbers, but we're actually adding those numbers together. Okay, so that's what we are doing today. And that's really what series is. Series is the sum of a sequence. Okay, so in particular, we're looking at arithmetic series. So then, as you can imagine, it will be a series of an arithmetic sequence. Okay, so here's the example: 2 plus 6 plus 10 plus 14 plus blah, 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 and so on. Okay, so the arithmetic series is the sum of an arithmetic sequence. Okay, so as I guess as I mentioned earlier that we're gonna look at the formula for the arithmetic series, and really this comes, well, I wouldn't say I derived it, but really we are looking at a pattern and coming up with a formula. Again, this is not a proof or anything like that. It's just looking for the pattern and then get the formula. For the sum, we use Sn because it's the sum of n terms. Okay, sum of the first n terms. So Sn, this is equal to, well, let's take a look at this, our first example, how we got 1 plus 100. Recall this number 1 is our first term. So to know first term, remember from last time was A. This 100 was our last term, and that really is just Tn times 50. Now, the question is, how did we get this 50? Recall the 50, the number 50 came from there are 50 pairs. Now, the question is, how can we figure out how many pairs there are, in total? Well, we have n numbers, right? 1 to 100, there are 100 numbers. So if the sequence start with the number a, or the initial term, ends with the last term, nth term, there will be n numbers. And to find out how many pairs they are, we simply divide that by 2. So to find the number pairs, you just go n divided by 2, right? The total number of terms divided by 2. That will give you how many pairs there are. Usually, we rewrite this as n times a plus tn divided by 2. Okay, so that's the formula for our sum of first n terms in an arithmetic series. Okay, so that's the sum formula. Now, I'm just going to write down the tn formula, the terms, the nth term, for arithmetic sequence. Tn is equal to a plus the common difference times n minus 1. We are going to use this formula today and this formula today. Okay, we're going to use both of them. Okay, let's look at our first example. It says determine the sum of the first 30 terms in the series 3 plus 5 plus 7 plus 9 plus blah blah blah. Okay, so just like last time, I am going to write down all the things that I need for Sn. Well, it says Sn is equal to n times a plus tn. Okay, so these are the 4 things that we need to know, or that we need to use for the sum formula. Okay, it says sum of the first 30 terms. So we know we're looking for S30, which means n is 30. And it says the first term is 3, so a is 3. We do not know what tn is. Okay, so that's the problem. We have 2 things that we don't know. This is where we need to use tn now. Okay, we need to use the other formula. Tn is equal to the first term plus the common difference times n minus 1. Okay, so these are the 4 things that we need to use. We don't know what tn is, but we do know we're looking for t30. Okay, so n, just like in the previous line, we know n is 30. Common difference we do know is also 2, right? 3 to 5 to 7 to 9. We keep adding by 2. The first term is a 3. So now we have all the information that we need to get t30. T30 is equal to the first term plus the common difference of 2 times n minus 1. And if you put this into a calculator, I believe this is 61. Or use your mental math. Okay, that's 61. So then we can put this here. Tn is simply 61. And now we can find S30. And S30 is equal to the first term, n times the first term, 3, plus the last term, 61, divided by 2. 3 plus 61 is 64. 64 divided by 2 is 32. 32 times 30 is 960. And that is S of 30. Okay, the sum of the first 30 terms. Okay, so that's our first example. The next question, the next example really is very, very similar to this. So actually it's pretty much the same thing, just different numbers. So pause the video and give yourself a try. Okay, I'm going to assume that you finished the question. I am going to write down the formulas up on the top here. Sn is equal to n t1, or I guess I use a here, a plus tn divided by 2. So similarly, we can write down all the things that we need. We're looking for the sum of the first 50 terms, so we're looking for S50. Therefore, n is 50. A, we know it's 1. We don't know what tn is. So exactly the same situation as the previous question. So we need to use the tn formula as well here. We're looking for t50. We do know a is 1. We do know the difference is 5. And we do know n is 50. Therefore, we can find t50 by using the formula. 1 plus 5 times 50 minus 1. This is 49, so 245, 246. So this is 246. Okay, so S50 will be n times a plus tn divided by 2. I don't know what this is. I'm going to use a calculator. This is 247 times 25, 6175. Okay, so that will be the sum of the first 50 terms. Okay, hopefully you did it right. If not, please check your mistakes. Number three is slightly different, not that much, but again, you just follow the same procedure here. This is not that bad, okay? Again, we're looking for sum, so we're going to use the SN formula. In this case, we don't know what n is. Okay, so that's the problem. We don't know what n is. We don't know what n is. We do know a, which is 5. We also know tn, that's the last term, which is 65. But again, we don't know what n is. Just like the previous question, if you don't know something, you probably will need to use the other formula, okay? So we will take the other formula and we'll try that. We know Tn is 65, right? So Tn is 65. We know the first term is 5. We know that the common difference is 4. 9 minus 5 is 4. We also know that, oh, actually, we don't know what n is, right? So that's the question. Again, out of these 4 variables, we need to know 3 of them to solve the question, okay? So now we have 3 things. We can just write out the formula. 65 is equal to a plus the common difference times n minus 1. Solve this equation. Minus 5 on both sides, you get 60 is equal to 4 times n minus 1. Divide both sides by 4, you get 15 is equal to n minus 1. Add 1, n is equal to 16. So now we do know n is equal to 16. Therefore, we can find S16 by using the sum of n terms formula for arithmetic series. So n is 16, a is 5, tn is 65, divided by 2. This is 8 times 70, which is 560. Okay, so the sum of the first 16 terms will be 560. Okay, so this one doesn't seem all that bad either. Okay, it's different unknowns that we need to solve for first. The next question, number 4, this one is slightly more challenging. Okay, so I again want you to pause the video and give it a deep thoughts. Okay, this one is quite challenging. Okay, if you haven't done it before. Okay. All right, I'm sure you struggle for a good 5-10 minutes, right? Yeah, whatever. Okay, anyways, so here, let's look at the question. It says the sum of the first 25 terms in an arithmetic series is 835. And it says the sum of the first 26 terms is 871. What is the value of the first term? Well, okay, so it tells me that S25 is 835. It tells me S26 is 871. That basically is everything that's it tells me. That's all the information I have. Okay, so that not very helpful. Not very helpful. Now, what we need to think about is how do we use these two information though, okay? Think about what S25 means and think about what S26 means. I'm gonna erase this. You know what? No, I'm not gonna erase it. Well, I erased it. But this really means T1 plus T2 plus blah, blah, blah plus T25. And S26 means T1 plus T2 plus blah, blah, blah plus T25 plus T26. Right, that's what that means. Now, what if I subtract these two things, right? If I subtract T1 minus T1 is 0, T2 minus T2 is 0. If I just continue to subtract, all these will be zeros. All I left with is T26. And if I subtract A71 with A35, I get 36. So really, this also tells me that T26 is 36. Okay, does that make sense? Okay, T26 in this case is 36. Again, based on what it means by S25 and S26, I get this result. Okay, so now I actually gain a little bit more information. Okay, I am gonna erase all these because I didn't actually leave enough room here for you to solve. 36 is okay, so I'm gonna erase all these. I'm gonna say S26 is A71. Again, T26, we just found out that was 36. And well, we know n is 26. We just don't know what a is, right? Oh, actually, I have enough information now, right, to solve for a because I have 4 variables with 3 unknowns. So I can actually solve this. So we just go A71 is equal to equal to n times a, which is, well, we don't know, I guess, plus Tn, 36, divided by 2. So we can simplify this a little bit. That's A71 equals 13. I go 26 divided by 2 first, and then a plus 36. Divide both sides by 13. We should get, I don't know what we get actually. A71 divided by 13, it is 67. So 67 is equal to a plus 36. Minus 36 on both sides, you get a is equal to 31. So that is actually our first term, okay? If the first term is 31 and the 26th term is 36, if you add all those terms together, S26 will be A71. Okay, so this one a little bit different because you need to figure out what T26 is first. And to do that, again, this is simply S26 minus S25, right? Because that's the extra term that you need to add to go from S25 to S26, right? The extra term that you need to add is the 26th term. Okay, so that probably is the most difficult question in this handout. If you got it, good for you. If you don't, just calm down and think about it. Maybe you'll get it. Okay. If you don't, you can always ask me again. Okay. Last example here. It says you visit the Grand Canyon and drop a rock off the edge of a cliff. The distance the rock will fall is 16 feet for the first second, 48 feet the next, 80 feet the third second, and so on in an arithmetic sequence. What is the total distance the object will fall in 6 seconds? Okay. So the question is, I guess the first second it will fall 16 feet, and then the second second it will fall 48 feet. The third second will fall 80 feet, and so on. And we're looking for 6 terms. Okay, well, this one's not too bad. We're looking for S6, right? 6 seconds. We know n is 6. We know a is 16. We don't know what T6 is, but that could be figured out quite easily by using, again, the Tn formula as T6. We don't know. We do know a is 16. We do know the common difference is 32. Again, this came from 48 minus 16. And we know that n is 6. Okay, so d again is equal to 48 minus 16, 32. So now we can find T6. T6 will simply be a plus d times n minus 1. Okay, so that would be 32 times 5 is 160 plus 16, that's 176. So we know T6 is 176. And then we can just find S6 using the formula now, because we know 3 out of the 4. N is 6, T1 is 16 plus Tn and 176 divided by 2. So this is 16 plus 176, that's 192. 192 times 3 is 576, I think. I better check. Nicole corrected my mistakes on the YouTube, so I better check. 576 feet it is. Perfect. Okay, so that's all there is in this lesson. Hopefully it's not too bad. Again, I'll post the assignment online later, and yeah, do it. And if I made a mistake, let me know as well. Comment below, I suppose. Okay, I'm not afraid to be criticized. I make mistakes, but that's okay. All right, have a good one, everyone. Good luck.